For all of human history, it has been our constant, a silver disk in the night sky. It governs our tides, stabilizes our planet, and measures our months. The moon is our closest celestial partner. But the solar system is a dynamic and violent place. We track thousands of objects, comets and asteroids. Most are harmless, but what if one wasn't? We ran the simulation. A large, high-velocity comet, 3I Atlas, on a collision course. Its target, not Earth, but the moon. The result is not just a crater, it is the end of the world as we know it. In our scenario, Comet 3I Atlas is a long-period comet. It fell from the Oort cloud, accelerating for millennia. Its composition is a mix of ice and rock, and it is massive. Its orbital path was tracked by every major observatory. Initial projections had it passing harmlessly through the inner solar system, but in this simulation, a gravitational interaction with Jupiter gives it a new, precise, and terrible trajectory. It will strike the moon at over 150,000 miles per hour. Why is this impact different? The moon has no atmosphere. Earth is protected by a thick blanket of air that vaporizes most inbound objects. The moon has no such shield. The impact will be a direct transfer of kinetic energy, pure, unimaginable violence. The event begins not with a sound, but with a flash. From 239,000 miles away, a flash appears on the moon's surface. It is brighter than the sun. It is visible in broad daylight across the entire planet. Anyone looking at the moon with a telescope or binoculars is instantly blinded. The impact itself is over in a fraction of a second. The comet vaporizes, along with trillions of tons of the lunar surface. An impossibly large plume of ejecta, molten rock, gas, and solid debris is blasted into space, escaping the moon's weak gravity. But the real horror is the shock wave. A seismic shock wave travels through the moon. It ripples across the surface, buckling mountains and shattering plains. Within minutes, a second, more powerful shock wave rebounds from the core. The two waves meet. This is the moment the moon shatters. From Perth, the moon appears to wobble. Then it visibly breaks. Fissures glow with the heat of magma from its interior. It is no longer a solid sphere. It is a cloud of debris. The moon, our constant companion, is gone. And for Earth, the nightmare is just beginning. The moon's gravity held this debris cloud together for a few hours, but now Earth's much more powerful gravity takes over. Trillions of tons of lunar rock are pulled toward our planet. This is moonfall. It does not arrive all at once. The fastest debris, blasted directly at Earth, arrives in under 8 hours. The bulk of it follows over the next few days. At first, it is the most spectacular meteor shower in history, but the shooting stars get larger, and they do not burn up. They are joined by objects the size of cars, then buildings, then mountains. The lunar debris storm begins. Unlike a single asteroid strike, this is a global event. No continent is safe. The impacts are sustained, continuous, and planet-wide. The energy released by this constant bombardment heats the atmosphere to oven-like temperatures. Surface water boils. Global firestorms ignite, consuming entire continents. The initial moonfall event is a true extinction. Life on the surface cannot survive. Only those in deep, prepared bunkers would have any chance at all. And then the second phase begins. The debris that didn't hit Earth, but didn't escape orbit, settles. Gravity and orbital mechanics organize the rubble. Within a few months, Earth has a ring. It is not beautiful like Saturn's. It is a dense, unstable ring of rock and dust, a monument to our lost moon. This ring is the final lock on humanity's prison. It makes space travel impossible. It shreds any satellites we launch, permanently ending global communications, GPS, and weather monitoring. But the moonfall and the ring are not the worst part. The worst part is the absence. The moon was our anchor. It stabilized Earth's axial tilt. Without it, Earth begins to wobble on its axis. This wobble, called a change in obliquity, is catastrophic. The 23.5-degree tilt that gives us stable seasons is lost. Over decades and centuries, the tilt can swing wildly. The poles could melt. The equator could freeze. Seasons become a violent lottery of extreme, planet-altering weather. And finally, the tides are gone. The daily pulse of the oceans, driven by the moon, simply stops. The sun still exerts a weak pull, but the massive intertidal ecosystems, the nurseries for much of marine life, collapse. Global ocean currents, which regulate our climate, are fundamentally altered. The engine of our planet's weather breaks. Our simulation shows that a moon in act is not a distant spectacle. It is an indirect execution of our planet. The moon is not just a light. It is a critical piece of planetary machinery. It is our shield. It is our stabilizer. It is the metronome for life on Earth. If 3I Atlas struck the moon, we would not just watch it die. We would be watching the 4-billion-year history of a stable, living Earth come to an end. We would be trapped on a dying world under a beautiful, terrifying ring of debris, the tombstone of our only moon.